we can get going.
Okay, good morning. Welcome to the Intel Academy. We will be doing some paper one. So I want to start with a little bit of algebra. Generally tends to only be one algebra question on the paper, but algebra is the basis of everything. And you'll see whether it's complex numbers or whether it's calculus, there is a huge amount of algebra that's involved on the paper. Then after that, we'll have a look at some calculus, the two major topics that come up in section B, calculus, and the other one that I want to spend some time on is financial maths, which is part of a series in patterns that tends to be the 50-mark question will be a pattern question of some description. But I would say this year they haven't really done a major question on financial maths for a couple of years now. And I think it is a question that lends itself very well to a 50-mark question. So I think you've got a fairly good chance of that coming up. So I'd like to do that on the third class. And then next week we will have a look at paper 2. All right, so let us start. What I have are these PowerPoints, and we'll have a look at that. What I'll do is go through, what are the kind of questions that come up? Simultaneous equations, a very, very common question, simultaneous equations, and you've got two basic types. The likelihood of linear equations with two variables is very low, but a linear equation with three variables and a linear equation and a quadratic are much higher. So if you have a line and a circle, if you like, or three lines, tends to be a regular question that comes up, and being able to isolate the three variables there. All right, then change the subject of a formula tends not to come up as a question exactly like that, but the manipulation of a formula or something that you're given and rearrange it is very, very common. All right, binomial expansions tends to be honest, tends to be more of a mock question than it is in the actual exam. There's been very little as such, but you never know when they're looking for 30-mark questions, which this year is the first time where they've got 30-mark questions. Always a handy little filler if they're looking for an extra 5 or 10 marks. It's a formula that's in the book, and use the quadratic formula. You can, with the quadratic equation, obviously the first thing to try and do is to factorize it. If it's not obvious, and you can use the fact button on your calculator, tends to help a little bit if you've got bigger numbers, 108 or 255, and you're not sure what are nice combinations to go in. It's not a bad way of doing it. Use the fact button and see what values come up there. Completing the square is another way of doing it, and quite regularly they will ask you to complete the square to find the maximum minimum point. If you don't follow what they tell you, if it says by completing the square, if you do it another way, and obviously the easiest way of finding a turning point is by using calculus. You won't lose all the marks if you do it by calculus, but you're not going to get full marks. If they do specify a certain method, then you really have to use that method. But the way I would look at it is, if you can't use that method, you don't want to get no marks. You want to get an answer, and you want to show some working. So any other method would be more than acceptable to get you a low partial credit. And then obviously with a quadratic equation, and generally it will give you a help in the question if it says to 2 decimal places, if it says in surd form, if it says a plus or minus b root c, something like that, straight away it's telling you to use the quadratic equation, the quadratic formula, which is on the front page of the formula book. All right, solve quadratic inequalities, and we will have a look at one of those very shortly. The big thing with an inequality is if you divide or multiply by a negative number, the direction of the sign changes. So what you have to do, the methodology there, is to multiply both sides by the square. A square is always going to be 0 or a positive value. So multiplying by the square of the denominator will always get you out of trouble with inequalities. All right. And you can use that for surds as well, and for modular equations come up irregularly over the few years. So use the factor theorem. If f of a is equal to 0, then x minus a is a factor. Very common type of question that comes up. And And the nature of quadratic equations comes up very, very regularly, being able to manipulate quadratic equations and look at how to find the solutions. If the discriminant b squared minus 4ac is called the discriminant, why? Because it discriminates between the different types of equations you can have. So if it's positive, you're obviously going to get two answers. You'll get a positive value. So the square root of a positive number will give you a value, and you can take the plus or minus value and you get two distinct roots. And what that means graphically is you'll get two places where the quadratic curve, which is called a parabola, where that cuts the x-axis. So if A is positive, the curve is going down. If A is negative, the curve is going up. And then if b squared minus 4ac is positive, you're going to get two solutions. You're going to get two roots where it cuts the x-axis. All right. If it's equal to 0, you get this kind of effect where the parabola just touches the x-axis. So the x-axis is a tangent to the parabola, and so the turning point will be exactly on the x-axis, and you'll get a double root, x minus 5 all squared. And then the third type is where you get a complex root. If b squared minus 4ac is negative, you're going to end up with the square root of a negative number, and that comes up as a maths error on the calculator when you do it that way. And I think it's important to remember not to write maths error. It does come up regularly when I mark Leaving Cert papers where people will put maths error as an answer. You need to say, well, you need to check your calculation to make sure that it is valid. That you haven't done a typo in terms of putting in the values. But if it is a negative value, you need to have a look at why and see what you're doing. And the one thing to avoid is to, I'll get rid of the negative number and then everything will be okay. All right. And what that means is if it's a negative square root, it means the equation looks like that. And when you graph it, it doesn't touch the x-axis. So it's either totally above or totally below, and you get complex or imaginary roots. All right. So what I wanted to have a look at is, and these are just past papers, and that's what I want to do. If for tomorrow, if you have your past papers, you're more than welcome to use them and put your solutions on that, or you can just write away on in the copybook or whatever. I do want to do at some stages the 2020 papers, which I know aren't in the past papers, and we might organise to supply you a copy of those that you put them on a drive that you can access and have the 2020 papers if you want them. All right, but what I would like to do to start with is 2018. It's a 25-mark question. I think looking at the some of the sample questions that have gone around, in a lot of cases, what they're doing is just giving you the extra 5 marks. So there's no major increase in the volume of the questions that are being asked. They're just slightly more generous with the marking scheme. How that works with the final variation on the exams, I'm not sure. I mean, if you have to do 4 from 6, to be honest, I would be looking at making the questions slightly harder, but I'm not sure what they're going to do exactly. So let's have a look at this. So we've got solve the simultaneous equations. So we've got 3 equations and 3 variables. 2x plus 3y minus z is equal to minus 4. 3x plus 2y plus 2z is equal to 14. And x minus 3z is equal to minus 13. All right. What we do with the simultaneous equation with 3 variables is, first off, to get rid of one of the variables. And I think it is really important, have a look before you jump. You kind of say, oh, well, look, I could multiply the first equation by 3 and use the second or the third equation, or I could multiply by 2 and use the second equation. But if you look at it, the third equation doesn't have y in it. So it's probably just as easy to get rid of the y value. So let's go. And I think the one thing that is fairly important, I can move that out the way, is write A, B, C, label the three equations, and then show the examiner exactly what you're doing. I mean, I've spent a lot of time marking these kind of questions where you really try, what is the person actually trying to do? You know, and you can muck around and spend a lot of time on it just because you don't see exactly what they're doing. And obviously the big thing with any of these is if you multiply the first equation by 3, you need to make sure that each term is being multiplied by 3. And that's obviously the biggest mistake that is possible, where you multiply the x value by 3, the y value by 3, and forget to multiply the z value by 3. So in this case, what we're going to do is we're going to multiply b by 3 and a by 2, and then we're going to subtract them. I actually like the idea of not multiplying by a negative number, but you do whatever you're most comfortable with. I kind of find the big advantage of just multiplying by the number and then making the decision whether you add or multiply, or add or subtract. It gives you the options of rearranging the equation, because you want to try and get the variable, particularly in the first place, that you want to get the variable positive, and you're not mucking about, oh, is it a positive number? Is it a negative number? All right. So in this case, we're going to take our b equation here. We're going to multiply that by 3, and that will give us 6y. We're going to multiply a by 2, which will give us 6y, and then we can eliminate the y by subtracting. Again, as I say, if you want to multiply one of them by by a negative number, that will allow you to add as well. So if we do 3b, that will give you 3 by 3 is 9x, 3 by 2 is 6y, and 3 by 2 is 6z. And make sure the one that is most prone to be left out is the 14. We have to multiply the 14 by 3. That will give us 42 is our value there. Then we take a, we're going to multiply that by 2. So that gives us 4x plus 6y minus 2z is equal to minus 8. And because we have the variable that we want to eliminate, we have a positive. We have a positive 6y and a positive 6y. We're going to subtract the 2 and work it out. The big advantage I see by not multiplying by the negative number, you're thinking about, and you're the one who's driving what you're actually doing. I think if you multiply, multiply and change, draw a line and change the sign, all of these kind of little suggestions on how to do this, you're not really thinking about what you're actually doing. All right. So this way, to me, makes you think about what you're doing. I want to subtract those to get rid of the variable. So that will give us 9 minus 4 is 5x, the y's cancel out, and then 6z minus minus makes it plus 2z, which will give us 8z, and then it's minus 8, which will give us 42 plus 8, which is 50. All right, but that equation now, equation D, makes it very nice and handy. We know that that has eliminated the y, and we have equation here which has eliminated the y. So C doesn't have a y in it as well, but it turns out that it's not that nice a number. It's actually not too bad when I think about it. You're going to multiply that by 5, so that'll give us 5x. So 5x minus 15z is equal to minus 65. If the number, if the constant is on the left-hand side, I think it's always handy to put the variables x, y, and z on one side and the number on the other. Just makes it easier to isolate what's what. All right, so again here we have 5x and 5x, so we're going to subtract. So that will give us 8z minus minus 15, which will give us 23z. And 50 minus minus 65 is plus 65, which will give us 115. Divide both sides by 23, which will give us z is equal to 5. Now, one thing I would say to you at this stage, if you get a really nasty answer, if you get 256 over 317, all right, what do? Have a quick look and see if you can see, is there something inherently wrong? Have I forgotten to multiply this by 3 or whatever? But if there's nothing obvious, keep going. Plug that number back into your equation to get the value. To get the value that you're after. All right. So sorry about that. My dogs don't like the postman. So let's have a look. We've got Z is equal to 5. Substitute that, and it's probably easier to go into C there. Substitute the Z in. That will give us X minus 15 is equal to minus 13, which gives us X is 15 minus 13, which is 2. And then we can find the Y value by substituting in any of the equations apart from C. So substitute in there, and that will give us Y is equal to minus 1. And I think it is nice at the end to actually write what the 3 values are. Either X is 2, Y is minus 1, Z is 5, or you can write it as a 3-dimensional coordinate, 2 minus 1, 5, just to make sure that it's very obvious what your answer is and what your final conclusion is there. All right. And that was for 15 marks. So tends to be a fairly high-flying question. It is one that can be quite time-consuming if you're not careful. So I think it is important that you look at timing the whole way through. You should have 30-mark questions, which is what the section A are. It means effectively you're going to have 20 minutes for each question. So your time shouldn't be an issue. You should use the time at the start of the exam, spend 4 or 5 minutes having a look through the 6 questions, see which of those 6 you're going to do. And definitely the first question you pick is the one that you think you're going to get 30 out of 30 for. You don't have to do question 1 and then question 2 and question 3. Go through the 6 questions, pick the one that you like the best. I mean, you might really, really like complex numbers. Do that one first. Or you might decide, I really like algebra, or I like doing series and patterns, right? Do that one first. Make sure that you do well with that question, and that will keep your confidence up for the rest of the exam. All right, so that's part A there. And now if we have a look at part B, we have solved the inequality. 2x minus 3 divided by x plus 2 is greater than or equal to 3. Obviously, x can't equal minus 2, otherwise you get a negative down the bottom, and we can't have that. So chat. Is there something in the chat? Shall I? Okay. I'll finish this question and then we'll see if there's any questions that have come up. So solve the inequality. What we're going to do, if we multiply both sides by x plus 2, yes, it will get rid of the denominator, and that would be the general way of handling these questions. But when it's an inequality, if we multiply by that number, if x is equal to minus 3, we've got a negative value there. And if you multiply an inequality by a negative number, the sign changes direction. All right, so that means to eliminate that, the methodology is to multiply both sides by the square. So the denominator in this case is x plus 2. So we're going to multiply by x plus 2 squared. And what will happen there, we've got the x plus 2 squared is going to be divided by the x plus 2 once. So, and then on the right-hand side, we've got x plus 2 all squared, which is quadratic. So we're going to end up one way or the other with a quadratic. If you just multiply by x plus 2, you're going to get a linear equation, and you will get one value. In most cases, you get one value for x, but it will give you the low partial credit. And you can see in this question, it's worth 10 marks. And it would be a shame only to get 3. So, it is one of those things that if you're not comfortable with it, write it down somewhere so that and practice a couple of them. So here, that will divide 1, so it will give us a quadratic equation on that side. 2x times x is 2x squared, 2x times 2 is 4x, 3 times x is 3x, and it's a minus there, and then 3 times 2 is 6, and it's a minus. And do that however you want. Do it as a little aside. If you like using the array method, and the array method is one I never really liked all that much when it first came up in project maths is, oh, this is a good way of doing it. I think it's very handy. And the big advantage I see with it is it gives you 4 spaces. And it means that you end up with 4 values. The biggest problem I see is where people, well, let me just, is where people multiply it out and they forget to do the middle bits, and you end up with 2x squared minus 6, and you end up leaving out the 4x and the minus 3. All right, so if you're not that comfortable with it, just do it as a little aside, make sure that it's right. All right, and then the other side, we need to square first. So it's x plus 2 all squared, then we multiply by 3. So x plus 2 all squared is just x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. And if you're one of those people who can do that in your head, it's great, but make sure it's right. I mean, it's very easy. I mean, I can do them in my head quite nicely, but it's very easy to make a little typo as you go. So be 100% certain of it. Rearrange it. So there's our values. We're multiplying that quadratic on the right-hand side by 3, which will give us 3x squared plus 2 plus 2 is 4 times 3 is 12, and then 3 times 4 is 12. So what are we going to do with that? We're going to bring everything to the right-hand side. So we're going to subtract 2x squared, x and minus 6 from both sides. So, think it's always going to be the opposite sign to do that. So it's minus 2x squared minus x plus 6, which will give you x squared plus 11 plus 18 is our quadratic. Now we're looking at an inequality, but what we need to do is to find where it cuts the axis. And we know that a is 1, so that means the curve is going to go like that. And so we're looking for where it's in this case, if we're reading it this way, so we want when the equation is less than 0, so we're looking for this area here. All right, so, but first off, we need to find the 2 roots, and the 2 roots are going to be 9 and 2 will give us 18, and because it's all positive, it's going to be plus 9 plus 2, and we want that to be less than or equal to 0. And I flipped it around because it looks nicer to have the equation there on the left-hand side. It always helps as well. We tend to read, well, we do read from left to right, and it's always better to do that. But we can read this way. That equation is less than or equal to 0, reading it from right to left. All right, and all I've done just to make it handier for myself is to put it on the left-hand side, and I'll read it there. But we are looking for the less than value. All right, so we're looking for the values below the x-axis. So we've got x plus 9 is equal to 0, which means x is minus 9. X plus 2 is equal to 0, which means x equals minus 2. So the 2 values that we've got there, I'll get rid of that, are minus 9 and minus 2. There are 2 roots, and we want less than, so we're looking for this area here. So we can write one inequality like that. Minus 9 is less than or equal to x. Now, be careful. It's less than minus 2. Why? Because x can't equal minus 2. All right, so that is for 10 marks. So that's 2017 question, whatever it was, I can't remember now. And Fionn, do we have any questions at that point?
Yep, so just a reminder for anybody that's joined late, if you have any questions at all, you can just pop onto the chat function. You can go where it says to and change that from everyone to me, so Fionn Kenna, and you can send them to me directly as well. My email should be in the chat function. If you have any questions throughout the week, just let me know. So the first question we have in was...
Sorry, what was the question?
The first question we have in is, where is the factor button on the calculator?
The fact button, it is under the DMS button, so under the square root button on the calculator. And I can even, I'll discard that. And if I go to new share, I should be able to do So let me just call this up. I have a little calculator. The only thing about the fact button is you have to press the equals button when you type in the number. Oh, I've got too many things I can't. I can get my calculator to open up. Let me try that one. There. Now, screen. There we are. So hopefully have a look there. It is this button here, and it's yellow, so it's a shift to get it. So if you want to type in, say, 45 equals, and then do shift fact, and it will give you, that didn't actually work, 45 equals, and then do that one doesn't. That's why it didn't work, because it doesn't have it. This one does. So I have to go into one, just back into normal. And if I do 45 equals and then do shift and fact, and it will give me the factors there. All right, 3 squared times 5, so 3 squared, you can have 9 times 5, 3 times 15, or 3 times 15, and you can work, it will give you all of the prime factors, which is handy if you want to do prime factors. So is that okay? Sorry, that older machine doesn't have fact button on, but this is the newer machine. All right, so we might go to what I want to have a look at is 2017 is what we're going to look at next. So you can see that. All right. And go into here. All right, so this is 2017 question 1. The algebra question does tend to be one of the early ones, question 1, question 2. A couple of years have been question 4, but all right, so 2017 question 1, and what it's asking you there, and I need to move that out the way so I can see it. Write the function fx is equal to 2x squared minus 7x minus 10, where x is an element of R, so it's a real number. So we can have any value, we can have fractions, we can have positive, we can have negative numbers. And we want to write it in the form a bracket x plus h squared plus k, where a, h, and x are all rational numbers. All right, so it means you're not going to have a surd involved in it. All right, and hence write the minimum point. Now, as I mentioned before, I mean, if you're really struggling with how to write that as a squaring form, you can use calculus, right? I mean, if you differentiate that, you're going to get 4x minus 7, which will give you x. So we'll get that will get you 4x minus 7. We want when that's equal to 0, which means 4x is equal to 7, which means x is equal to 7 over 4. Right, so that will give you your x value, and then you substitute that in and give you the y value. So yes, you can do it other ways, but when it says in the form here, right, if you don't do it in that form, you're going to lose the big chunk of the marks. So you need to make sure that you do try and do it in that format if you can. All right, so let me get rid of that. What are we going to do? The way of doing this is we're going to take the 2 out as a common factor. All right, and if we take the 2 out, it gives us x squared, that's fine, but we then have to halve 7, so that's 3.5, and you can either write that as 7 over 2 or this one. So we can write it as 2x minus 7 over 2, if you prefer to do it that way, minus 10. I, again, tend not to put that 10 in. I know some methods do it that way, but I like it just to keep it as an aside because, you know, in the end, that K is the variable at the end, and that's the one we're going to adjust according to what we're going to do with the other bits. All right. So, and that's obviously x squared minus x. Okay, so what can we do with that? We want to make that into a perfect square. The only way we can do that is if the value of the right-hand part of the factor has to be the same. And so we need it to be twice, or we need it to be half that. So when we add the two together, we get the 7/2. So what's the value? And we already saw when we did it with calculus, it's 7/4 is what we want. All right. So it's going to give you that. A half of 3.5 is 1.75 or 7/4. So we can write it as x minus 7/4 all squared. All right, so that will give us the 7/4, will give us the two bits that we want for the middle. All right, 7/4x plus 7/4x will give us 7/2, which is what we want. I will admit him. All right, but what have we added? We have added 7/4 squared, and we've added it twice. So we have to take that away. So we have to adjust what we've added. We can't just merely add something. So we have to adjust it by subtracting whatever that value is. So 1.75 squared multiplied by 2 is 6.125. All right. And that will give us, when we add that to the 10, which was there originally, will give us the 16.125. The reason I put this question in, I did this question, is for this reason. All right. It is a dog of a question. And if you're not really good at completing the square, it's about as diabolical as you can get. All right. So how can you do it any other way? You know, you can do a little bit of playing with it, see if you can get something. And obviously to take that 2 out is very, very obvious. So to get the A value as 2, bang, you've got yourself the large majority of the marks. You know, that will get you 2 out of 5. And then how do you find the minimum point? Use calculus. All right. So there are ways and means of getting questions if you're not really sure on what to do. And, you know, you will end up getting the bulk of the marks. The big thing you don't want to do, and particularly when you've got a 30-mark question, is to leave it blank. You know, and I suppose the advantage you have by having the variations in the questions, you can, all right, I've had a quick look at that, bang, I'm going to move on and try a different question and see if I can get more marks that way. All right. So in terms of this now, sorry, I'm back. I just had to put that down so I could write a little bit nicer. So hence find the minimum point. The minimum point is going to occur when that's equal to 0, which means the x value has to be 1.75, 7/4. And then if that's equal to 0, then the value of the function at that point is going to be minus 16.125. So completing the square is a great way of finding a maximum or a minimum point. But as I say, the only time that they've really asked it over the last probably 6 or 7 years has been that one, which is, as I say, a fairly nasty little question. All right. And generally they tend, if you look at any of these in the textbooks, you'll see that there's plenty of them there, which are very nice and straightforward, and they work out to be whole numbers. And we do like playing with whole numbers. The reality that most of the numbers that you actually get when you do these things in real life are fractions or even irrational numbers. But it does say here that they're all rational numbers. So what was the marking of that? So they gave that 10 marks. I think generally that would have been the other way around, but you know, 10 to work out the completing the square and 5 to write down the minimum point. So if you're able to get the minimum point and you could have done calculus to get that, you would have got yourself the 10 marks. All right. Then we'll have a look at this. There's our function. We've written, you know, we can write it in the form of a completing the square. Explain why the function must have two real roots. How do we do that? We know that the a value is 2, the b value is -7, and the c value is -10. If we work out what our discriminant is, b squared minus 4ac, that is what differentiates the different types of equations. So if it's real, that should be a positive number. All right, and in this case, -7 squared, and be careful that you do put the bracket in it when you do it onto your calculator. So it is bracket -7 bracket squared, -4 times 2 times -10. And again, make sure that you bring that -10 value there, and that will make it minus as a plus, so you get +80. And obviously, if you leave that out and you make that +10, you're going to get -80 there. You're going to get a negative square root, and you've then contradicted what it said there. All right. And if it says explain why they must have two real roots, if you get a negative answer, say, well, they're obviously not real, they're imaginary, or they're complex, think about what you're saying. They're not going to make a mistake like that. You might get that occasionally in a textbook where they've made a little typo somewhere, but you're not going to get that in your Leaving Cert. All right. So if it says it, then it's true. All right. So b squared minus 4ac is a positive number, and you don't even have to work that out. You can just say that that's greater than 0, and therefore there are two real roots. All right, and that is for 5 marks. So we're up now to 20 marks, and then the last bit of the question is write the roots of f in the form a plus the square root of q, where a and I need to move that out of the way so I can see the whole question. A plus root q, where a, b, and c are elements of q. So we want rational answers there. All right. So we're going to use the minus b formula, and we get values. And what I would say to you is always work out, write that down, write your values. Show the substitution in, and then you can do it all on your calculator. Now you can't there is no plus or minus button, so do the plus version and you get your values, and that is as far as the calculator will give you. All right, it will give you that. You need to, if you do the positive one, you just need to make sure that you add the plus or minus bit, and that will give you 7 plus or minus the square root of 129 over 4. Is that in the form? It's actually not. All right. And a little bit, and this comes up occasionally in complex numbers as well. So the number is 7 over 4. So we're going to take that section of it out. All right. So that's the number without the square root. And then we want plus or minus, and then we want the square root of 129, and we want to put this inside the square root. So 4 inside the square root must be 16. The square root of 16 is 4. So it is that to get the full marks. And I think I do have the marking scheme there, but I think it was, if you didn't write it in that form, if you left it as that, you would have got yourself 4 marks. So just be careful when you look at the question that you're answering the question exactly. And so, that extra mark has come there. I only kind of did that question because I thought it was a little bit of a nasty one, and you just have to be careful with it to maximize your values. To be honest, if that question came up, it would be one I would be, I suppose, a little bit less reluctant, less interested in doing, and have a look if there isn't a nicer question to have a look at. All right. So, Fionn, are we going to do a little? We're actually almost at time. Do you want to put a little poll in and see if we're happy with the speed of what I'm doing? I mean, it's hard to know with the first class exactly how we're going. I hope I've tried to pitch it as at kind of a middle level, and I do apologize if you're a really bright mathematician and you see these things very quickly. It might be just a fraction fast for you, but all right, well, we're getting too slow. That's great. Oh no, the bulk is just right. All right, that's perfect.
Yeah.
Perfect. All right, so I'm not getting any that it's too fast, which is always my concern. All right, and I do apologize for those 6 who said it's too slow. Yeah, I think you have to pitch it for the majority. All right, perfect. Thank you. So that's great.
No problem.
So what I want to do just for the last couple of minutes, where are we? Yeah, we can do one more, 2020. So if you haven't seen this question before, here it is. And what we have is we have fx is equal to x squared plus 5x plus p, where x is an element of R, so it's real numbers, and p must be between -3 and 8, and it has to be an integer, so it has to be a whole number, but it can be positive or negative. Find the value of p for which x plus 3 is a factor. So what's coming up here is the factor theorem. So, I tried to, and you can see 2020, 18 and 17 have pretty much covered the bulk of the question types that come up. All right, so if x plus 3 is a factor, it means the root is the opposite sign. The root is -3. All right, and if -3 is the root, what does a root mean? What is the solution of a quadratic equation? What is the solution of equation? It is the value which will make it equal to 0. So if we substitute in -3 into our base equation, it should equal 0. And if we do that, -3 squared, please always put it into brackets to make sure that you get the +9. 5 times -3 is -15. So we end up with 9 minus 15 plus p is equal to 0, which gives us a negative value there. So it gives us -6 plus p is equal to 0. We add 6 to both sides, and that will give us p is equal to 6 as our value, which is, I think, the handiest 10 marks you're ever going to get. So, these algebra questions, you have to be careful with them. Read the question at the start and see, is this where I want to go? The 2017 one we had to look at, I'd be fairly reluctant to do that one. But this one here, kind of look at that and say, oh, yep, that's definitely worth the while. Now, you won't know that it's worth 10 marks, but you know that it's a handy little question and you should be able to get the bulk of the marks. All right. So find the value of p for which fx has roots which differ by 3. So lots of ways you can do this, but if a is a root, that may, well, -a is a root, that means x plus a is a factor, and it means if the other root is 3 more, it's going to be x plus 3. It's kind of a handy way of thinking about it. If you do it that way, I think it comes out very nicely. All right, so we've got a number, whatever that value is, and in this case I've called it a. You could call it k or whatever you want to, as long as you don't call it p. So a is handy enough, and then the other one must be 3 more than it, so it must be a plus 3. Multiply that out, and that means we've got x times x is x squared, x times a plus 3 is xa plus 3, a times x is ax, a times a plus 3 is a bracket a plus 3. All right, or you could multiply the whole thing out if you want. Multiply a by, and then a by 3 as well. You could do just as easily, because that's what we're going to do. I think it's actually better to leave them in a factorized form, because what it means is we've got the x's, we know all of the x's are 2x plus 3, and we know that that has to equal 5. All right, so there's one equation. So 2a plus 3 has to equal 5, and we also know that a bracket a plus 3 has to equal p. So if we take this first one, 2a is equal to 5 minus 3. If we subtract 3 from both sides, it's going to give us 2a is 2, which gives us a is 1. All right. If we do the other part, if we do the constant, a bracket a plus 3 has to equal p, which will give you, if we substitute in a in there, it will then give us 1 times 4, which means that p is equal to 4. It is wonderful to work out this, that a is 3, but what we're actually looking for is to find the value of p. Don't kind of think, oh, I finished, I've done that. What are we looking for? We're actually looking for the p value. So p is 4. All right, and that was for 5 marks. All right, and I hope that's okay. And then the last part of this is part 3. Find the two values of p for which the graph will not cross the x-axis. All right. If it doesn't cross the x-axis, what does that mean? It means that the discriminant has to be less than 0. All right. It means it's imaginary roots. All right. And it's not going to cut the axis. It's either above the axis or below the axis. So it's either going to be a curve down above the axis or a curve up below the axis. So if we substitute in what we know, we've got our p-value is there. So we're going to substitute that in. I can't. Sometimes these things get in the way. All right, so we've got 5 squared minus 4 times 1 times p has to be less than 0, which means if we rearrange that, 4p is greater than 25, or if you do it from that side, 25 is less than. All right, you can view these either way, either that way, or if you read it that way, 4p is greater than 25, which will give us that p is equal to 6 1/4. All right, and that, if I scrabble that out, okay, and so our p-value can be, is greater than 6.25. It says here that p can be between -3 and 8, so that means p in this case can be 7 or 8 are the two possible values. So I think relatively straightforward. Where is that 5 coming from? It's the b value. A is 1 and the c value is p. So we've just substituted into b squared minus 4ac, and we know that if it doesn't cut, it's less than 0. So again, I think we've kind of seen the major type of questions that come up. Simultaneous equations, inequalities, and the use of the discriminant b squared minus 4ac. All right. I hope that that's okay. And I think at that stage we might leave it. Fionn, if there's any questions, I might answer now.
Yeah. We'll just maybe 1, 2, just for the time. So do you always multiply by the square of the denominator with inequalities?
Yes, always. Because if you just multiply by the denominator, you're not taking into account that that number can be a negative number. Whereas if it's squared, it's always a positive number. So you always have to do that. And that is a very important methodology.
Great. And maybe just one more. When solving a simultaneous equation, can you solve via substitution?
You can, and I think that's a great way of doing it. It doesn't really work that well with 3 variables, but it works very, very well with when it's linear equations, and they will come up regularly in patterns and that kind of thing. So there's plenty of areas where you will get 2 variables, and substitution is a great way of doing it. And I think it's probably one that isn't emphasized enough in the syllabus. And I know I teach in a boarding school, and we have a lot of students that come from Germany and Spain. They would tend to do simultaneous equations by substitution. That would be their first point of method to do by substitution. So I think it's a great way of doing it, and would definitely recommend it. Except when it's 3 variables, it gets a bit nasty at that stage.
Brilliant. Thanks.
Okay. So thank you very much. I'll see you tomorrow, and we'll have a look at some calculus.